Okay, so let's graph our first function. So we're going to identify our function rule. It's right here. Okay, this is the expression that's going to make my output y. And I'm going to, this one's not too hard to do in your head, right? I just have to take the input number and subtract 1 from it. So -5 take away 1 more is -6. -2 take away 1 more is -3. 2 take away 1 is 1, and 4 take away 1 is 3. So there we go. Now what I've done is I have created a table of ordered pairs, and this is a set of ordered pairs. That means they all belong together because they all belong with the function rule from up above. So I can put all of these points, this set of ordered pairs, onto the same graph, okay, and look at their relationship with each other visually. And then I'm actually going to be able to see the function rule. So graphing these using what we learned in lesson 1, here is my origin. I'm going to make this really big so it's easier for me to count. Okay, so on the X number line, see, these are all of my ordered pairs. And if you makes you feel better, you can do this so they look more like an ordered pair or a coordinate point. Put your commas in your parentheses. So the first ordered pair is -5, -6. So count out -5 on the X number line. So remember your origin is 0, so -1, -2, -3, -4, -5. And then I need to go to -6 on the Y number line. Remember X. This one's Y. So that's down below 0, 6 below 0. So 1, 2, 3, 4, 5, 6. So this first point is located right there. And I will erase some of these extra lines that I made. The next point, so I did that one. Check, just to keep track. Now, next one is -2, -3. So -2 is my X value. So that's -1, -2. And then I'm supposed to have -3 for the Y number line. So that means I'm going down below 0, 3 lines. 1, 2, 3. So that point is right here. Get rid of my little counting marks. You don't need to do counting marks. It's just because you can't see my hand physically doing it. So did that one. Next point is at 2, 1. So that's on my X number line. Those are positive numbers. So 2 off this direction, the positive direction, is right there. And I need to have a +1 on my Y number line. So that's 1 up above 0. So that's right there. And I can put my point down. And then the last one to do is at 4, 3. So 4 on the X number line, 1, 2, 3, 4, and then 3 on the Y number line will be 3 up. So 1, 2, 3, and I can put my point there. Now, I hate to say it, but drawing and joining these together on the iPad is just really hard for me. I apologize for being so ineffective. I will try to do my best. I need something that will act as a straight edge because I didn't bring one in with me. And this probably won't work very well, but we'll do it anyway. Okay. Whoa. It's really hard to, oh shoot. See, what's really hard to do is to put it on the screen without activating everything. Oh, stop it. Oh man, I went to the back page. Okay. I'm going to freehand it, guys. I can't do it. So connecting my points together, and you will line your ruler up. I can do insert a line, I think. Can I? This is not the time to be investigating, Mrs. Grace. There we go. Okay, in red, fine. If I anchor it here, okay. Whoa, that is not what I wanted to do. I don't want snapping. I want to draw a line. Line? Line. Try now. Yes. Oh, sweet. Okay, there we go. I have connected them to, oh, I'm pretty good. Nice. All right, I have connected my points together with a line. And you'll see that they make a beautiful, perfect straight line. And that is part of the reason why we call these linear functions. In fact, you might call it a linear function. Ooh, ha, 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 ha. It's called a linear function because when we have a function rule and we have an x instead of an x squared or an x cubed or all the terrible things that can happen to x, we just have a nice normal x. We end up with a straight line when we use it as a function and generate a set of ordered pairs and put them on a coordinate plane. And you can visualize that it's a linear function by the nice straight line that it makes. And we're going to study other things like where is it located, compared to the origin, and how much tilting does it have? Is it really steep? Is it really flat? We'll be able to figure out all of those things later. But just for right now, be amazed at the beautiful, perfect universe that God made and the fact that when you graph a linear function, you actually get a straight line. It's kind of cool. All right, looking then, and now that I figured out the line function on my iPad in the middle of my video, let's see if we can use it again. So we're going to look at one more of these. Let's look at number 4. I'm going to spend all my medium and difficult ones on ones where we have to figure out our inputs that we're going to use as well. So I'm going to do number 4 next. Number 4 has this as its function rule, -2 times my input minus 4. So remember, we'll always do the multiplication part with -2 first, and then once we have that number, we'll take away 4 from it. So they've given us some inputs to use that they've suggested. So we're going to take those numbers that they're giving us and we're going to put them into our function rule. So I'm going to take -5, that's here, the first one in my row. I'm going to take that -5 and I'm going to put it in. So -2 times -5 is +10. 10 minus 4 is 6. Now I'll use my -2 in my function rule. So I'm going to take -2 and I'm going to multiply it by -2. That gives me +4. And then I take away 4 and I get 0. When I use 0 as my input number, -2 times 0, well, that's just 0. So 0 minus 4 is -4. And then finally, if I put a 1 in, anything times 1 is itself. So -2 times 1 is -2. And if I take away 4 from -2, I get -6. So here's my set of ordered pairs that I have generated using this function rule. Let's take this set of ordered pairs and graph them to see what kind of line they'll make. And they will make a line because I have an x without an exponent on it. So graphing these, here is my, make it bigger, just easier for me to graph. Here is my origin, O for origin in the center there, where it's 0 on both number lines. My first x value, my first input is -5, so that's off to the left. 1, 2, 3, 4, there's -5 right in here. And my y value is +6, so I'm going to go up 6. 1, 2, 3, 4, 5, here's 6. So my first ordered pair is right there. For the next one, my input is -2 on my x number line, so I count out 2 out by the negative. So there's -2 right there. And then 0 for y on the number line. Well, I'm already at 0 on the y number line, right? So I will just place my point here. Get rid of my counting mark. And I've done the first 2. Next one, 0 on the x number line, so that's just right at the origin. And then I'm supposed to have a -4 on the y number line. So starting at my 0, down 4, 1, 2, 3, 4. So that point will be right here. And then the last ordered pair is 1, -6. So 1 on my x number line is here. And -6 is down below 0 on the y's number line. Remember x, y, I don't always label them. 1, 2, 3, 4, 5, 6, right here. All right, will they all connect together in a straight line? They will. Let's see if Mrs. Grace remembers how to use this. Okay, so if I put it here, and then I just have to drag, oh, and can I move the whole line? Yeah, getting it in there. Not the most awesome way to do it, but it's not bad. There we go. Sweet. There's my line, right? Really, and the arrows on the end, you guys, just mean that I could keep putting in more inputs and keep getting more outputs. I mean, I can use the whole real number system and use it as an input and keep getting all these outputs out. And so this line is actually going to stretch forever in either direction as my inputs stretching off and up to the left as my inputs get smaller and smaller, stretching down and to the right, my inputs are getting larger and larger. And so that's why we put the arrowheads on the end to show that it's really every little place along this line is going to be a pair, an XY pair of answers that will work in our equation or our function, depending on how you want to look at it. Even the things in between those points, you could put in little fractions for your inputs, and they will still fall along this big red line for the outputs.